Today, I want to talk about how LLMs can distort beliefs. This is the subject of a paper that I recently wrote with my colleague Abiba Bahrain. In this paper, we argue that the risks to human belief distortion are greater with things like LLMs than previous technologies that serve information to people, like, for example, basic searches. And the reasons are largely based in cognitive science, which is why we thought talking about this paper in this venue was a good match. The reason why relates to the subset problem, which cognitive scientists understand better than anyone. The problem is that there's a lot more information in the world than we have the time or ability to explore. And so people in the world are forced to choose just a very small subset of all of the exhaustive information on which to form their beliefs. A lot of my lab's work has focused on the processes by which people select learning just a subset of that information to learn from. In an older paper with Ben Hayden, we outlined the specific attentional mechanisms humans are theorized to use in order to solve the subset problem, to avoid information overload so we don't get overloaded. Number one, we seek uncertainty. Number two, we use feedback to determine our certainty. And number three, we disengage when we are certain. People base our beliefs on the informational subset that they obtain from this curiosity cycle. They start doing this in infancy, but the same process is theorized to guide attention throughout adulthood. So now, into these basic processes, we introduce the advent of generative AI systems like LLMs. Generative AI, and especially LLMs, have been held up as a tech that can offer quick access to a digestible serving of information. Yet, these models contain known racial, gender, and class stereotypes and biases, which downstream into model outputs. For a visual example of this, I'd like to refer to Leonardo Nicoletti and Dina Bass's recent Bloomberg piece on gender and racial biases in the Stable Diffusion model. The work showed that Stable Diffusion's text-to-image model amplifies stereotypes about race and gender beyond what's true of stereotypes in the world, and likely also beyond what was even true in the model's training data set. For this work, Nicoletti and Bass generated thousands of images related to job titles and crime. They prompted the text-to-image model to create representations of workers for 14 jobs, in total 300 images for each of 7 high-paying jobs, and then 7 that are considered low-paying. Plus, they also asked about 3 categories relating to crime. Next, they analyzed the skin color of the generated faces for these job titles. This analysis found that the model generated lighter skin tones for high-paying jobs and darker skin tones for the low-paying ones. Next, they analyzed the perceived gender of faces that the model generates. Just as with skin color, the model exhibited gender-based biases. It generated male perceived faces. Those are the ones that are shown in dark green there, for the high-paying jobs like lawyer, doctor, CEO, and engineer. It generated female faces like those are the ones that are shown in light teal there. For low-paying jobs, those include ones like teacher, social worker, and housekeeper. It also generally had a bias to generate male faces. So overwhelmingly, you see a lot more dark green on the screen than you see teal. You can note that most occupations in the data sets are dominated by men, except for the low-paying jobs like housekeeper and cashier. Finally, they generated images for keywords inmate, drug dealer, and terrorist. Again, the model amplified these biases. More than 80% of the images generated for the keyword inmate were people with darker skin, even though people of color make up less than half of the US prison population. These biases, this is just an example of one set of biases in one model, but they've been demonstrated not just in text-to-image models. These represent just some of the people who've done work to document these kinds of biases in all sorts of other generative AI systems, including LLMs. So this is a general problem that we are dealing with. Further, these models also regularly fabricate information for reasons that are not going to resolve anytime soon. Developers have acknowledged the fabrications and biases, but suggested that people must use these systems to reveal the problematic outputs in order to remedy them. So this is a quote from Sam Altman from late last year that says this is going to take continual iteration and lots of societal input to get right. This approach ignores that the distortions cannot be easily corrected once they are transmitted to people. That's taken as an assumption that we're going to argue is not right. Okay, so with that as my introduction, I want to outline 3 key aspects of human cognition that I think explain how generative AI distorts human beliefs. And I'll get right into it. The first one is that people form stronger, longer-lasting beliefs from agents that they judge to be confident. Model outputs from LLMs take the form of short, confident statements, regardless of whether or not they are accurate. This is precisely the type of input to people you might worry could result in rapid, stubborn belief adoption. There's a large literature about how people form stronger, longer-lasting beliefs when they receive information from agents that they judge to be confident and knowledgeable. This is one example from Mark Saba and Dare Baldwin's work that shows that even children learn better when they're learning from an agent who asserted their knowledgeability in the domain as compared to one who did not. I want to note here that this is showing that even very young children track agents' knowledgeability and use it to inform their beliefs and exploratory behavior. This fact supports the theory that this ability reflects an evolved capacity that is central to our species' knowledge development. It speaks to exactly how robust of an effect this is. Although humans sometimes communicate false or biased information to each other, the rate of human errors is an inappropriate baseline in this case. It's an inappropriate baseline because the types of exchanges between generative AI and people versus people and people are very different. Further, people have rich systems for communicating their uncertainty through their words, their response patterns, and their gestures. Their responses are hedged by phrases like "I think," response delays, corrections, and speech disfluencies. By contrast, generative models unilaterally generate confident, fluent responses with no uncertainty representations, nor the ability to communicate their absence. So these are fundamentally different in this way, and we argue in the paper that this is just one reason why things like LLMs are at greater risk for distorting human beliefs when they're presenting people with biases and fabrications. Okay, second thing. More exposures to fabricated information results in more deeply ingrained beliefs. More exposures means stronger belief, even when the false statement contradicts a person's prior knowledge. This is an example of this from some great work by Lisa Fazio. These plots are showing greater repetition predicted greater strength of a person's belief in a false statement. This fact is true even when the statement contradicts a person's prior knowledge. So even if you start aware that something false is not true, your strength of belief in that false statement still increases as you see more repetitions. Trends that increase people's exposure to fabrications consequently increase the strength of people's beliefs in false information. The trend of integrating generative AI models into existing technologies, things like search engines and smartphones, will almost certainly mean greater exposure to models' fabrications and biases. So this is a big issue as LLMs replace things like search and are adopted as the back end of ed tech systems by large numbers of people. Okay, third thing. The window in which people are open to changing their minds is transient. The window closes once a person receives the information that they requested from a model, which then resolves their uncertainty. People are going to these systems. They're requesting information from generative AI models in particular moments when they are uncertain and thus most open to learning something new. Once a person has received an answer, their uncertainty drops, curiosity is diminished, and they don't consider subsequent evidence in the same way. As just a few examples of this, I'd recommend checking out this paper that I'm citing by my former student Charlene Wade, and also work by Louis Marti, showing how quickly feedback leads to high rates of certainty in people. We are still in the nascent stage of this technology. In the paper, we argue that this means that we right now have a transient opportunity to measure the impact of generative AI on human beliefs and biases. This opportunity rapidly diminishes once these systems are more widely adopted and more deeply embedded into other things. I want to close by emphasizing how much more work I think we have to do on how LLMs are changing human beliefs. We think research on how generative AI affects children's beliefs should be an especially high priority. Children are more vulnerable to belief distortion because of their increased tendencies to anthropomorphize technology and their more nascent, influenceable knowledge states. To close, technologies that offer information to people should be sensitive to human psychology. I think we can do this better, and I think cognitive science has a lot to say about how. Thank you so much for listening to my talk, and I know this is an online talk, so you can't immediately ask me questions, but if you'd like to email me or Abiba, we'd be happy to answer questions via email. Thanks. Bye.